Hello, my name is Vichai Her, and I am majoring in electrical engineering. I will be presenting my control systems DC motor project. To begin with, a direct current or DC motor is any electrical machine that converts direct current, electrical power, into mechanical power. So how does a DC motor work? A DC motor is rotated by the torque created from the magnetic force when electrical current passes through the copper coils. There are poles in a DC motor, and the magnetic field is directed from north to south. Thus, the moving magnetic field converts electrical engineering energy into rotational mechanical energy. DC motors are important because they have high torque, great acceleration, are quick to start, stop, and reverse, even with a heavy load. For example, a blender, like shown below, utilizes a DC motor. This specific blender can go up to 3,000 to 15,000 RPM. The design requirements for this project is to have an overshoot of 5% and a zero steady state error. The shown block diagram simplifies into the equation omega of S over V of S. MATLAB will be used to create a visual explanation of the root locus to determine the gain values along with the feed-forward and feedback lines with amplitude in respect to time. These are my inputs and equation used for the DC motor project. J is the moment of inertia of the rotor, B is the motor friction constant, K is the electromotive force constant, R is the resistance, and L is the electrical inductance. Using the step function, the step response graph below was given. Here, the final value in the step response should be approximately 1. The SysOtool function was used to draw the root locus. Adding a grid will help visual the measurements easier. Next, I adjusted my percent overshoot to less than 5%. Notice the change in the graphs. After finding your real zero, edit your compensator. To improve the time response of the system, the compensator gain is increased as shown. The final system response shows that we have a percent overshoot, approximately at 5%, with a zero steady state error, which is within the design requirements. Exporting will give you the given solution. 58.138 multiplied with S plus 0.6, all divided by S. Below are the references I used to get information and pictures for this presentation. If you have any comments or questions, you can email me with the email info below. Thank you for watching my DC motor project presentation.